Hi, in this video, I will be showing you problem number 10 from the practice exam 1. Solve the compound inequality 4x minus 6 more than negative 10 or 3x minus 4 more than or equal to 2. Write the solution in interval notation. If there is no solution, enter 5. So there are few things you have to make a note of. How are the compound statement connected by? Are they connected by or and? If it is or, I will show the method. Then I'm also going to do the same problem with combined with and. So you will see the variation to this problem. So we'll have to solve for each inequality separately, and then we'll have to take care of what happens, how you connect them if the two inequalities are connected by or. So first let's consider 4x minus 6 more than negative 10. Then we'll keep the or as is. Then 3x minus 4 more than or equal to 2 separately. So for the first one, you have to isolate the x. So add 6 on both sides. So we get 4x more than negative 4, strictly more than negative 4. Now you divide both sides by 4. Thus you get x more than negative 1. This is one inequality. Keep in mind you have to take care of the or separately. Then you consider this 3x minus 4 more than or equal to 2. Isolate the x term. So you get 3x more than or equal to 6. Divide by 3 both sides. That will give x more than or equal to 2. Even though the question is asking us to do the answer in interval notation, it's always useful to graph it and then convert the graph into interval notation. So we have now two numbers, negative 1 and 2. But in negative 1, you have strictly more than negative 1. So you have to make that as a whole. Here you see greater than or equal to 2. So make that as a solid dot. Then here x is more than negative 1. So all to the right of negative 1 must be shaded. Let me do that with the red color. Then x is more than or equal to 2, the second one. So let me do that in green color. When the two inequalities are connected by or, then you have to consider the totality of all the elements in both sets or both intervals. So the actual shading, if you look at this entire graph, the actual shading starts at negative 1 and ends at positive infinity. So you have to consider all the elements in the first interval and all the elements in the second interval. So you have to consider the entire shaded area. So it starts at negative 1, then it ends at positive infinity. So in interval form, the solution is negative 1 through infinity, but negative 1 has a hole, so you have to have only a parenthesis notation. It's open. Then infinity or negative infinity can never be closed, so it is open again. So open negative 1 through infinity. So the all values of x lying between negative 1 through infinity is the answer to this problem. Now I'm going to show you if the same problem has instead of or, if the two inequalities are compounded by and, how do you modify the answer? So we have to do the problem the way we did, but how we connect them is the question, right? So let's find out 4x minus 6 more than negative 10, and we'll write and 3x minus 4 more than or equal to 2. Just as the way we did the previous problem, we have to solve the x separately for these two inequalities, and only when you do the AND part, you have to see how you want to give the answer. So add 6 to both sides. So you get 4x is more than -4. You divide by 4 both sides. So you would get x more than -1. So one part of the solution. Then remember, you are going to connect this one with the AND compound statement. So do this one separately. This inequality is solved. So that will be 3x more than or equal to 6. Divide by 3 both sides. That would give x more than or equal to 2. Till this part, it's exactly the same as the previous problem, number 10. Now the question is how you want to graph these two. So let's graph and then convert the problem to one of interval notation. X more than -1. So it's -1 as a whole because you don't see the equal to sign in this inequality. Here x is more than or equal to 2. So you make it as a solid dot. I'm going to shade x is more than -1 part in one color, and let me use the red. So it's x more than or equal to -1, more than -1, all to the right of -1. Then I'm going to shade x more than or equal to 2 in a different color. So it starts as green. I'm going to shade that way. So when you say and, you have to write down, you have to actually consider what is common to both these two sets or both these two inequalities. So one is shaded red, the other one is shaded green. The common one, which is the meaning of and, is the one that is colored in both, which is 2 through infinity. So the answer to this problem, if it is connected by and, the compound inequality, so the answer would be 2 through infinity. You have to be also careful with what kind of parentheses you use. 2 is here included because it's a solid dot. So inclusive 2, exclusive infinity. So that is a solution in interval form. So be aware of the modifications that you might get on the homework questions or on the practice exam. So the left hand side problem number 10, that is on the practice exam, shows or. Then I have shown on the right hand side how the same problem can be done if the two inequalities are compounded by the compound statement and. Hope this video helps.